Alright guys, today we're going to be solving combination sum. So basically, in this problem, we're given a list of integers, and we have to just return the sum, or uh, another list of integers, where if we just add them all together, it'll equal up to the target number. So for example, our target number is 9. We could go ahead and use 2 times, and we could use 5 once, and that would add up to 9. An alternative would be using 9 and just using 9 once, and it'll also add up to 9. If you understand it, so nums, which is our numbers list, there's always going to be unique elements. So you're never going to see like two twos in nums, just because we could already reuse them twice. Okay, so the way we solve this is actually by using um, a backtracking tree. So for example, this is what it would look like. We'd have the numbers 2, 2, oops, we have the numbers 2, 5, 6, and 9, and our target is going to be equal to 9. So first we start with our root. It's right here. So we have two choices. We could have a 2, or we could have no 2. So in this subtree, we're going to have 2, and this one we're going to decide to have nothing at all. And then for this tree, we could have decide to add a 5, and for this one, we could have nothing at all. And for this subtree, we could have a 2, because we could use the same number twice. And for this one, we could just choose to have nothing at all, which is just 2. And we just keep on doing it until we reach a case where it does actually add up to 9. For example, it would be, an example would be this one. So we'd do 6, or we could do nothing, and then we could do 9, or we could do nothing, right? And then we could see that 9 is going to be equal to target. So we could just return the 9 into our answer list. And we can see it's one of here. We could also go find the answer using a 5 and 2s. So we could go ahead and just for this one, we could do, actually this subtree won't have it, but this one will. So for this one, we could go ahead and add another 2. So 3 2s, or we could just add a 5. Or actually it'll have nothing like this. Oh, and this version will actually add that 5. Then we'll see that this equals up to 9. So we go ahead and just return it. We'll return this. All right, now let's go get into the code and see how we would solve this. So we can see that the left side will be to add the number. Right side will be to leave number out. Okay, so how can we solve this? We can solve this actually by using a def first search. Let's go ahead and define. What should our def first search have? I think it should include our index, our current subset, and it should also have our total. So we should have something called answer, and for now it'll just be empty, and we'll just add our current subset to answer if it adds up to target. So for that one, it'll be like this. If total is going to be equal to answer, then we could go ahead and just do current. We could do answer dot append current subset dot copy. Then after doing that, we could go ahead and just return. Another condition would be, let's say if it's not big enough, right? Let's say if index is out of range or anything, then we want to go ahead and backtrack. Or let's say if it's not big enough, so this is adding up to 4, right? So if index is less than Actually, yeah. The other condition would say if it's out of index. We want to backtrack. So how can we do that? So we could check if the total, what was it? If index is greater, go to the length of nums, or our total is already greater than our target, then we could just go ahead and return. All right, what are the other conditions? The other conditions are if we still have to add up to reach the target number. Okay. So what can we do? We could go ahead and add our index. So we could do total. We go ahead and just append the current index. And we go ahead and just append our nums of this index. Okay. We added the number to the subset. Now, what should we do? We should go ahead and call def for search on, let's see, the index. Index will be the same.
Mac and cheese ready.
The current subset. Yeah, okay. The current subset will be the same because we just added it. And total, for the total, we're going to do total plus nums of index. And then for the right side, where we don't add anything, for the right side, we want to remove. So what can we do? We could do pop. Right, now we could call def for search on index plus 1, current subset, and just total would be the same. Now that we've done that, we go ahead and call our function by calling def for search. And for that, we'll input our, let's see, our index. We'll start on index 0. Our current subset will just be an empty subset. And then for our total will equal to 0 so far. Now we could just return answer. Let's see if this works. Okay. I know what's wrong. Oh, shoot. how you saw it.